8.1, we're going to simplify rational expressions again, and that's going to include multiplication and division. Basically, we're reducing fractions. So when we look at number 1, we know that b squared is like b times b. And so what happens here is this b on the bottom is going to cancel only one of those b's on the top. And so whatever this fraction reduces to, we know there's going to be a b on the top. Other than that, we reduce the fraction like we would reduce any other fraction. 24 over 54. Well, I know both of those numbers are divisible by 2. So if you divide by 2, that reduces down to like 12 over, what, 27? 54 divided by 2 is 27. And then you're like, well, both of those numbers are divisible by 3. So if I divide both of those by 3, that's going to be 4 over 9. And that's reduced. That's the reduced version of the fraction. So I'm going to have a 4 on the top and a 9 on the bottom. And then, oh yeah, don't forget, there's this negative sign right there. So you can put the negative in the front or on the top, either way. You usually don't put it on the bottom. Front or top, either way. Number 3, absolutely, positively do not cancel those b squareds. Do not do that. You can't cancel something. We talked about this last time. You can't cancel something if it's next to a plus sign or next to a minus sign. You can only cancel factors. Factors are things that are being multiplied. So what we're going to have to do is recognize that this is an easy trinomial and factor it using that pattern. And so once you get good at this, you can get going pretty fast. But I know an easy trinomial is going to split into 2 binomials like this. And I'm looking for 2 numbers that multiply to 63. And so if you know the numbers, you need to multiply to 63 and add or subtract to -2. Sometimes you can just see the numbers, and if you can just see the numbers, write them down. If you can't, then I write down all of the different ways of doing it. 3 times 21, 4 doesn't work, 5 doesn't work, 6 doesn't work, 7 times 9, and there it is. Usually when I write it down, I'm like, yeah, that's it. It's got to be the 7 and the 9. I want to multiply to a -63, and that tells me that one of my 2 numbers is negative. But in order to make them add up to -2, I know that the 9 has to be the negative one. So it's going to be b minus 9 and b plus 7. I just factored that. I just factored the expression. I'm going to do the exact same thing on the bottom. The bottom is also an easy trinomial. And so the bottom will also factor into this. The b times b makes the b squared. Imagine if you're working backwards, if you're distributing, b times b is b squared, and there's this, and there's this, and there's this. We're kind of undoing that multiplication process. So I need 2 numbers multiplied to 21 and add up to 4, basically. 7 and 3. Specifically, one of them has to be negative, so which one? The -3? Yeah, I think that's right, because that's going to make them add up to +4 and multiply to -21. There we go. So we just factored the bottom. And now we can cancel. Now we can reduce. We're talking about reducing common factors. Well, I see a common factor of b plus 7. And so that leaves me with b minus 9 over b minus 3. Now, can I reduce the 9 and the 3? Absolutely not. Can I cancel those 2 b's? Absolutely not. You cannot cancel something if it's being added or subtracted, only something that's being multiplied, only factors. This is your final reduced answer. So then number 5, it's kind of the same thing, maybe a little bit easier. I see an easy trinomial on the top here, so we're going to factor that into 2 binomials. X squared must have come from x times x. I need 2 numbers to multiply to 54 and add up to 15. Does anybody know those numbers? 9 and 6, very good. So plus 9 plus 6. Those 2 numbers multiply to 54 and add up to 15. And now I also see something that can cancel. I've got x plus 6 that's going to cancel, which leaves me with an x plus 9 on the top of a fraction. On top of what? Well, I guess on the top of 1, but we don't really need to say over 1. So we're trying to simplify, and I can simplify this. I don't need to write it as a fraction. That's just x plus 9. X plus 9 on the top is just x plus 9. Okay. Hopefully you can feel yourself getting better at these problems, because we're just doing kind of the same thing over and over again. On the bottom, do not try to say 5 goes into 25 because that 5 is next to a minus. You cannot touch that 5, but what you can do is say, oh, this is a Gcf pattern. I know this is a Gcf pattern. And what's in common for those two numbers? 5. Both of those numbers are divisible by 5. And so think about it as 5 times what would be equal to what we started with? Well, 5 times 3p with a minus sign, and 5 times 1. Okay. Now I can reduce with this 5 because it's 5 times. All right. 5 times something. 5 is a factor. I can reduce with my 5. This 5 goes into 25 5 times. So I'm left with 5 on the top, 3p minus 1 on the bottom. That's all I can do. I wish I had written that smaller. I'm gonna try that again. I'm gonna use my space better because I'm gonna need it for this next problem. This was 5 over 3p minus 1. All right, when I look at number 9, I see a big old mess. It looks really complicated, and I want you to get in the habit of, anytime it looks complicated, we want there to be a GCF. All right, so look for a GCF. Try to program yourself to look for a GCF every time. If there's a GCF, it's probably going to make your life easier. Probably going to be easier to factor. So in this case, I see all three of those numbers are even numbers, so I know they're all divisible by 2, but they all also have at least one x in them. So there's a GCF of 2x. So I'll write that down. And then in parentheses behind it, I'll write whatever I'd have to multiply by to get back to the start. Well, 2x times x squared would be 2x cubed. And then there's a minus sign. And then 2x times 12x would be 24x squared. And then there's a plus sign. And it's 2x times 35, very good, would be 70x. Now, can you see the relationship between multiplication and division? You know, 2 times 35 is 70, but another way of thinking about that is 70 divided by 2. So sometimes you might be thinking about dividing, and that's fine. But I just factored a GCF, but notice what we just produced is now an easy trinomial pattern. And so we can also do that easy trinomial pattern on this. I've got that 2x in the front, but my easy trinomial is going to split into x times x. So I need two numbers to multiply to 35 and add up to negative 12. 7 and 5 add up to 12. That's correct. I need a negative 12. Both negative. That's very good. If you do minus 7 and minus 5, those two things multiply to positive 35 and add up to negative 12. That's it. So I just completely factored the top. Now I'm going to do the exact same thing on the bottom. Okay, on the bottom, get in the habit of looking for a GCF first, especially when it looks hard. Do you see the GCF? 2. Very good. If I take out a 2, I must have an x squared here, a minus sign. 2 times 11 is 22, so minus 11x plus 30 right here. Very good. Now, did I just produce another easy trinomial? This looks like an easy trinomial to me. Easy trinomial. So don't forget the 2. And then your easy trinomial, x and x, I need two numbers that multiply to 30 and add up to negative 11. 5 and 6. The better you are with your multiplication table, the better you'll be at this lesson. 5 times 6 is 30. 5 plus 6 is 11. I know this is going to be minus 5 and minus 6, like that. They're both negative because they have to add up to negative 11, but they have to multiply to positive 30. Okay, so now I haven't simplified yet. I've just factored. Now simplifying means, can we cancel anything out? So what do we see here? I see an x minus 5. That's kind of the first thing that I see that's going to cancel out. And I see something else that cancels out. Do you see it? How about this 2? That 2 is going to cancel out. So I know it's kind of a big old mess here, but look at what you have left over. What we have left over on the top is this x times x minus 7. And what we have left over on the bottom is this x minus 6. Notice when you need parentheses. I need parentheses around the x minus 7 just because it has to hold off that x. I do not need the parentheses around the x minus 6 because it doesn't, parentheses wouldn't really hold anything off or do anything. There's your answer. All right. Now, number 11 looks kind of hard, but really it's easier because it's already done. The factoring is already done for us. All we have to do is say, well, let's just start canceling stuff. I can cancel an n plus 8. And I can cancel, notice how this squared means that there's n plus 5 twice. Right, all that means is there are 2 of them. So I can cancel out that n plus 5 on the bottom with one of those n plus 5s on the top. So there's going to be one of them left on the top. There's going to be one of those n plus 5s left on the top. And there's going to be an m minus 1 over here on the top. And there's going to be an m plus 4 on the bottom. And again, notice how you need parentheses on the top because that n plus 5 has to hold off the m minus 1 and vice versa. Okay, they have to be separated from each other, and those parentheses are what's going to do that. All right, the m plus 4 does not need parentheses to hold it off. All right, now let's get into the tough stuff because now we're going to multiply, but really it's just factoring. Let's factor and let's cancel. Up on the top, you see how that's an easy trinomial? Oops. N, thank you. 2 numbers multiply to 3 and add up to -4. Right, so -3 and -1. I like to just write it right on top and then kind of slash it out. That was an easy trinomial. Notice this one is a GCF over here. What's in common? 10 is bigger. 5 works, but 10 is bigger, so 10 is better. 10 is the greatest common factor. 10 times must be n plus 1. Nothing to do on the bottom left. The bottom right, though, is another easy trinomial. So n, need 2 numbers to multiply to -3, add up to -2. 2 and 1, those don't multiply to 3, though. This one's tricky. Sometimes they're tricky. It's got to be 3 and 1. One of the numbers has to be negative. Which one? The 3 has to be the negative. So -3 and +1. There we go. Now we're all factored. It's just a matter of canceling stuff we can cancel. So what cancels? N minus 3 is going to cancel. This 10 is going to cancel. N plus 1 is going to cancel. So all I'm left with is n minus 1 on the top. You can say n minus 1 over 1 if you want, but the simplest way to just say that is n minus 1. N minus 1. Okay. Next, this one's already done for us. It's already factored, so this one should be easy. We can cancel out x minus 1. We can cancel out x plus 6. We can cancel out a 2. Bottom is just 1 now. All I'm left with is an x and an x plus 8. Okay. This one's going to be the hardest one, 17. Okay. Because this is, like you look at the bottom left there, the 5k squared, that's not a GCF. That's a hard trinomial problem. Okay, this is the hardest one because this is a hard trinomial. Hard trinomial. And so a hard trinomial, you're like, well, where did that 5k squared come from? It would have come from 5k times k. And so if I'm going to factor this, it's not as easy as the easy trinomial. It's a little bit harder. We have to think about numbers that multiply to 10. Just write it down, okay? Write it down. Make sure you can figure this out, all right? We need numbers that multiply to negative 10, so I know that one of the numbers is negative. Notice those numbers do not add up to 23. And the reason for that is because if you think about how this distributes, whatever number goes right here is getting multiplied by 5. So what I have to do is figure out how can I multiply one of those red numbers by 5, and then they'll make 23, either by adding or subtracting. And so you might be able to tell, well, if I could do 5 times 5, that's 25. And then if I subtract 2, that's 23. Okay, but time out. I don't want 23. I want minus 23. So let's just change the signs. That's plus, that's minus. That would be negative 25 plus 2 is negative 23. There you go. All right, so what that tells me is, since the negative 5 is getting multiplied by 5, that has to go over here, minus 5. And since plus 2 does not multiply, it's going to be right there. That's factored. That's a hard trinomial. That's the hardest you have to do right there, okay? Now, top right is also a hard trinomial. But the thing about it is, I mean, 15k squared could either be 15k and k, but I suspect it's going to be 5k again because I know the name of the game is canceling out. I suspect it's going to be a 5k just because I bet it's going to cancel that 5k plus 2. In fact, I bet it's going to be 5k plus 2. But let's just see. We need numbers that multiply to 20. And they're not going to make 44 unless you multiply one of them by 5. This number over here is getting multiplied by 5. So, you know, check it out. If I do this, that's going to be, oh, you know what I messed up? Does anybody see what I messed up? Because I did make a mistake. I need a 3 in there, don't I? Otherwise, it's not going to make 15k squared unless I put a 3 right there. So I screwed that up. Okay, I messed that up. So that 5, I'm going to do 10 times 5, and that's 50. And I'm going to do 3 times 2, and that's 6. I can do 50 minus 6 and get 44. All right, that's kind of how this works. Sorry, I messed that up. I don't want 44, though. I want negative 44. So that means we're going to make this one negative. That's negative 50 plus 6 is negative 44. So I put the minus 10 over here in the position that's getting multiplied by 5. But notice this position is getting multiplied by 3. So that's where my plus 2 goes. Plus 2. Factored. Okay. Now on the bottom, we've got a GCF, right? Bottom here, we've got a GCF. Both of those numbers are divisible by 9k. And then we'd be left with 3k minus 10. Excellent. So we should be able to see a bunch of stuff that cancels now. All right, I've got 5k plus 2, gone. 3k minus 10, gone. So if you do a rewrite, you can do a rewrite here, but I've got one more thing that cancels. You've got a 6 on the top, that's all that's left. And on the bottom, you've got a 9k and a k minus 5. Technically, there's one more thing that gets canceled. The 6 and the 9 can reduce. The 6 and the 9 can reduce. Both of those numbers are divisible by 3. 6/9 reduces to 2/3. So technically, we would write 2 over 3k times k minus 5. That problem's rough because of the hard trinomial, not because of the overall material. It's just because it has so many hard trinomials. The other ones aren't so bad. Now, number 19, we're dividing fractions. So remember how we divide fractions. We multiply by the reciprocal. Multiply by the reciprocal. And then it's just the same thing as what we've been doing. Okay. I can cancel anything on the top with anything on the bottom. So it's 9/6 reduces to 3/2. Those 10s can knock each other out. And so if you look at the top, I know it's kind of hard because I've scribbled a lot of things out, but look what you've got. You've got a 3 and x and an x, that's x squared. And on the bottom, you've got 2. 3x squared over 2. All right, getting close. Is this the last one? No, 2 more. 3 more. All right. Now, you've got a whole bunch of easy trinomials, right? And so I'm going to multiply by the reciprocal. Well, let's do it this way. I'm going to multiply by the reciprocal v squared plus 2v plus 1 and v squared minus 4v minus 5. Let's flip it. Multiply by the reciprocal. Okay. Then I've got to start canceling junk out. All right. Man, this got a lot going on. So do your easy trinomial thing. 2 numbers are multiplied to 5 and add up to -6. -5 minus 1. 2 numbers are multiplied to 1. Right? Well, the problem is you can't do this because it ends up that this one's on the bottom. And so you can't cancel a bottom with a bottom. You know what I'm saying? So that's a little bit tricky. And I think this is almost like a trick question because that's something that I might have seen to do too. But yeah, those things, if one of them is on the top and one of them is on the bottom when you multiply, yes. But when you're not multiplying yet. Okay. Good observation. I want 2 numbers to multiply to 1 and add up to 2. That's 1 and 1. Okay. So v squared minus 4v minus 5. 2 numbers that multiply to -5 and add up to -4. That's -5 and plus 1. But it's just going to be the exact same over here. So we are multiply now. And so if we're multiplied, this is where the stuff cancels out. All right. I've got a v minus 5 that cancels. I've got a v plus 1 that cancels. I've got another v plus 1 that cancels. All I'm left with is v minus 1 over v minus 5. Okay. '23. We are dividing, so make sure you change it to times the reciprocal. Division times the reciprocal. Do not do this on multiplication, only on division. And then we need to start canceling stuff out. Okay. So 3 goes into 9 3 times. Now you can say, well, these 2 3s will cancel out. Nothing else cancels out. I've got a 9 on the top, a squared on the bottom. All right, last one. Division. So times the reciprocal. Division is times the reciprocal. So now, all I see here is a easy trinomial. I need 2 numbers to multiply to 6, or actually -6. This one's tricky sometimes. There's 2 different ways of making 5, so you have to really be careful how to get the -6 and the -5. How am I going to get -6 and -5? People are like, well, if I make both of these negative, I can add up to -5. But why doesn't that work? That'll make a +6, right? So that can't work. It's got to be +1 and -6, right? That's going to do the trick. That's going to multiply to -6 and add up to -5. All right. Now, v minus 6 cancels, v plus 1 cancels. All I've got is v minus 1.